Greetings, parasite ecologists. In this lecture, we're going to dive into the schistosomes, a really special group of trematodes who take variations on the trematode theme to a whole new level. These are really different from the remainder of the trematodes in a lot of ways, including their life cycle, their life history, and their impact on people. The schistosomes are an awful burden on public health. The schistosomes also offer a great example of how we can use parasite ecology knowledge to really benefit the people who need it the most. Let's start by situating ourselves taxonomically in the parasite tree of life. Here we are among the phylum Platyhelminthes, class Trematoda, family Schistosomatidae, and here there are three primary species we are interested in: Schistosoma mansoni, Schistosoma hematobium, and Schistosoma japonicum. Three different trematodes that cause three different but similar diseases. Here are a few children who are enrolled in a study that Chelsea and I were involved in the West African country of Senegal. We found that they were positive for schistosomiasis when we tested by examining their urine and stool samples. Urine for Schistosoma hematobium causing urogenital schistosomiasis, and stool samples for Schistosoma mansoni causing intestinal schistosomiasis. Here are a few of the urine specimens, and the pathology of schistosomes is obvious in some of these samples. Healthy urine samples are clear and yellow, but we're seeing some specimens that are cloudy and red. This is hematuria, or blood in the urine, and it is one of the classic signs of urogenital schistosomiasis. If we are able to look inside their bodies, we would see that the veins around the bladder of these patients are full of living worms. These are the adult worms, living permanently in copula and producing eggs. Of course, this is a video of worms inside a mouse, not a person, but this scene would look much the same inside of a human patient. Chelsea made this video by euthanizing a mouse and immediately dissecting it so she could catch the worms while they were still alive. So these worms are in the circulatory system, and the eggs are being released into the circulatory system, but they need to find some way to make it to the outside world. Under normal circumstances, if everything is going well in your life, your circulatory system is not open to the outside world. These worms have an ingenious solution. Their eggs have spines, and these spines snag the walls of the vein. Then the egg is slowly moved across the wall of the vein and then across the wall of the bladder or of the intestine, all by the human immune system. The immune system recognizes the egg as foreign, surrounds it with immune cells, and tries to get rid of it, moving it outside the host. Ultimately, the egg gets dumped into the lumen of the bladder or the lumen of the intestine, which is exactly what the egg and its parents have wanted, because now it can be released with the urine or the feces into the outside world, where it can find a snail to infect. But the problem is that the immune system is not perfect, and not all of these eggs make it into the outside world. About 2/3 of them get stuck along the way. This is a cross-section of a human urinary bladder taken from the autopsy of a person who had urogenital schistosomiasis. All of those football shapes are eggs that weren't successful in their journey, and now they have become permanently stuck in the wall of the urinary bladder. If you get enough of these eggs stuck there, you can get some really severe pathological consequences, including lots of granulomas or calcified structures around these eggs. A granuloma is a hard knot of tissue that includes calcium, collagen, and connective tissue, and it can be 100 times the size of the egg itself. It forms around the egg as human immune cells recognize that egg as foreign and recruit to that site to wall it off from the rest of the body. Unfortunately, the cure that the immune system is trying to enact can cause a lot of damage to the body. This is an X-ray. An X-ray is supposed to show calcified structures, so we can see the hip bones and the femurs, and all of that is good and normal. But what's that thing in the middle? That's the human urinary bladder. A normal urinary bladder shouldn't show up at all in an X-ray because it's soft tissue. But in a severe case of human urogenital schistosomiasis, you can see the bladder lighting up on an X-ray because it is calcified. If you look really carefully, you can even see the ghostly outlines of the ureters leading out from the kidneys. They, too, have become calcified by eggs from Schistosoma hematobium. And this is what causes the symptoms of bloody urine in the Senegalese children. Similarly, Schistosoma mansoni can cause bloody feces. The mouse is a really good model for us to see what is happening inside a human body when that human body is infected with Schistosoma mansoni, which causes intestinal schistosomiasis. Livers usually look the same, no matter what vertebrate you're looking at. It's a large lobed organ that sits over the intestine, and a healthy liver is uniform in color, usually red, smooth, and firm. Check out this healthy liver on this mouse. Now check out the liver on an infected mouse. You'll notice that it's not uniform in color, it's mottled. It's huge compared to the healthy liver, and its shape isn't smooth, it's discontinuous and lumpy. This is a liver full of granulomas formed around Schistosoma mansoni eggs. Anywhere calcified tissue has replaced healthy liver tissue, the liver's function is being compromised. Remember, this is bad for the eggs. They will never fulfill their destiny sitting inside a mouse liver because they need to be able to get to a snail. They need to get out of the host. But they don't have much control over where they end up. And when you are carried into the hepatic portal vein, it makes sense that you will end up in the liver rather than in the lumen of the intestine where you were intended to go. A few other things to notice. In the healthy mouse, there is a small, dark spleen. It's red, sitting alongside the liver. In the schistosomiasis infected mouse, that spleen is enormous, inflamed, and swollen up with granulomas. Same with the intestines. In the healthy mouse, the intestine is slender, pliable, but in the schistosome infected mouse, the intestine is large, bloated with granulomas. You can imagine the toll this takes on all of the mouse's bodily functions, from digestion to detoxification to immunity. In fact, before we even open up these mice, we might be able to notice the difference between an animal with Schistosoma mansoni and one without. An uninfected mouse, like the one on the left, will be slender, well-groomed, with a very consistent coat. No bare patches. In the infected mouse on the right, we see that the abdomen is distended, The coat is patchy. This animal is suffering from ascites, a buildup of fluid in the abdomen. We would see the same thing in a human patient. Human patients can also suffer from ascites. All the disturbances to the tissues of the bladder and liver can also cause bladder or liver cancer. And on top of all of that is abdominal pain. A few of these photos can be difficult to look at, but I think it's important for us to fully confront the horror of parasitic disease and the impact it has on people, especially so if you're watching this from a wealthy country in the global north, where schisto isn't a fact of everyday life. Children bear the majority of the burden of schisto infections. This is a little boy in the Philippines with ascites as a result of infection by Schistosoma japonicum. And this is a boy who has ascites due to intestinal schistosomiasis. The other panels show images of the kind of intestinal pathology that is also happening inside the patient. In these photos, the black arrows show approximately the same part of the intestine. You can see that the granulomas in the intestines are interfering with normal intestinal function, like absorption and peristalsis. This is a life-changing illness, sometimes a life-ending illness. It's not common to die of a schisto infection. About 200,000 of the 200 million infected people die each year. But these people's lives are weighed down by their infections, suffering from ascites, pain, and risk of bladder cancer and liver cancer. Malaria is more directly a killer. But if you consider the years of healthy life lost, schisto is not far behind in terms of its global burden. This is a disease that causes people to suffer greatly, even though they die less often than malaria. This is a part of why it is a neglected tropical disease. We tend to lavish research attention and philanthropy on diseases that kill people directly. But schisto causes a massive amount of suffering and deserves a lot more research and donor attention than it gets. Now, schistosoma isn't new. It's something that's been with us for a really long time. These are ancient Egyptian hieroglyphs that include a symbol for schistosomiasis. People were peeing blood red in ancient Egypt. Schistosoma eggs have been found in mummies from as early as 1200 BCE. But even though it's been with us for a long time, we're still learning new ways in which schistosomiasis affects people. I mentioned that schisto eggs can go through the wall of the bladder and through the intestine. But remember that they aren't moving on their own. They just go with the flow, hoping that their spines will snag on just the right spot. But ultimately, they can end up elsewhere in the body. Some can even wind up in the wall of the vagina. As it turns out, only in the past few years have we been able to understand the impact of urogenital schistosomiasis on women. These eggs can be lodged in the wall of the vagina. They develop granulomas, and they create these rough patches where the epithelium of the vagina is made more permeable and more porous. The presence of these eggs makes it 3 times more likely that woman will contract HIV from an HIV-positive sexual partner. Schistosomiasis is not only a public health burden on its own, but it also exacerbates the burden of the HIV/AIDS epidemic. The point of all of this is that the pathology of schistosomiasis comes not only from the adult worms, which on their own just eat some blood. It comes from the eggs that those adult worms produce. Wherever the eggs land, the granulomas that form compromise tissue function. They turn healthy functioning tissue into calcified non-functioning tissue. This can have a lot of downstream effects. Thanks for letting me drop into your video series. Enjoy your time in the world of parasites, and I'll see you later on in the series.